Hi, in this video, we will be covering the last two steps of the hypothesis testing, and that is on comparing the test statistic that we have computed in step number 3 and that of the critical value. And then in number 5, I will discuss how to write the decision and conclusion after performing the first 4 steps. Okay, to show you how to do this, let us use our example, and that is on the average length of sleep of teenagers aged 15 to 19. And we have said that the null hypothesis for this study is that the average sleeping hours or the average length of sleep of the teenagers is 7. And the hypothesis that challenges this belief or existing information is that the average sleeping hours is no longer 7, so the mu is not equal to 7. Now, in this study, let us use a significance level equal to 1%. And let's say that if we have asked 50 people, so that will be our sample size, and is equal to 50. And again, after we gathered some data, let us just assume that the outcome is 6.38 for the sample mean, and the sample standard deviation is 1.25. So these values are assumed. So we don't have any existing list of values that we got from the 50, but let's just say that these are the outcomes. The sample mean is 6.38 and the standard deviation is 1.25. So again, as we can see, we don't have any information of the population, standard deviation, and that the sample size is greater than 30. So the appropriate test for this is the z-test. And since the alternative hypothesis says that the mu is not equal to 7, then this means that we have to use a two-sided test. And that means one critical region should be on the left and another critical region should be set on the right. Now the red regions or the critical regions will be the value of the alpha. So if we have set the alpha to be 1%, then the alpha over 2 is half of 1%, which is 0.5%. So in decimals, this is 0.005. So the areas here are both 0.005. So when we compute for the z value or the z-test statistic value, we use the formula x bar minus mu sub 0 over s over the square root of n. And we say that the decision rule is that we reject HO when the z is less than the negative of z of alpha over 2, or when the z is greater than the positive of z of alpha over 2. Now in the diagram, we should be able to see that as, so if this is the normal distribution curve, and these are the critical regions, when we say that the z is less than the negative z of alpha over 2, that means z is under the critical region. When the z is greater than z of alpha over 2, that means the z is also on the critical region on the right. And when that happens, critical regions are the area of rejection, so that is why we have to reject the HO. Now if the case is the z is in between those two z of alpha over 2, then the conclusion is we fail to reject HO. So from there you have already seen the idea in step number 4, and that is when you compare the value that you will be obtaining in the z, and you compare it to the z of alpha over 2 on the left and on the right, which are called the critical values. To show this with a specific example, so our data says that we have n is equal to 50, x bar is equal to 6.38, and s, the standard deviation of the sample, is 1.25. So if we have the z is equal to x bar minus mu sub 0 over s over the square root of n, then this means we have x bar is 6.38 minus mu sub 0, the hypothesized mean, which is 7, divided by, so that's a 7, divided by s, 1.25 over the square root of 50. And this is equal to negative 3.5072, or approximately negative 3.51. So with all this information that we have, we can now perform step number 4. Okay, so you have your diagram, and then you create. So you show the critical regions, and with the corresponding z of alpha over 2. So again, we use 1%, so we have the negative of z.005, and then you have the positive z of 0.005. Now in this step, you need to know the critical numbers. The critical numbers are the boundaries of the critical regions. And then you should have this list ready. So we refer to our list of z values. So the z of 0.005 is equal to 2.58. So that means our boundaries are, so this z of 0.005 is equal to 2.58, and that is the number here. And then on the other side is the negative 2.58. Now noting that the center of this curve is 0. Once you have identified the critical values, you go back to step number 3, and that is the computed value for the z. And we have solved for that value, and that is negative 3.51. So get this number and place it on the diagram. So if the z value, this is the computed z, the test statistic value, is negative 3.51, find its location in the graph. So imagine this to be a number line with 0 in the middle. This is negative 2.58. That's a negative 2.58. This point is at positive 2.58. So if we are going to place the negative 3.51, it must be located on the left of negative 2.58. And that means if negative 3.51 is at this location, that means it is under the critical region. And the critical region is the area of rejection. Okay, immediately after this step, we can now make our conclusion, and that is our number 5. So as we can see in step number 4, since the z is less than negative 2.58, then that means the decision is we have to reject HO. In other words, there is sufficient, so this is the standard way of writing your conclusion. There is sufficient evidence to support H1, and that is H1 mu is no longer equal to 7. So as you can see, this is an example in which we have rejected a status quo. The average sleeping hours is no longer 7, because it is currently believed that the average length of sleep is equal to 7, and since we have conducted a study now based on 1% significance level, we can now reject the HO, and there is sufficient evidence to support the alternative hypothesis H1, which is mu is not equal to 7. In other words, the average length of sleep is no longer 7 hours, and just to specify at 1% significance level. Okay, so that's how you do your step number 4 and step number 5. Now, just to provide you an example, so what if the conclusion is fail to reject? Okay, suppose that the value that we obtain in step number 3 is not in the critical region. So our conclusion will be fail to reject. So to write this, you just have to reverse your statement when you reject the HO. So you just say there is no sufficient evidence. So there is no sufficient evidence supporting H1. That means the average sleeping hours, the length of sleep of teenagers age 15 to 19 is still 7 hours because there is no sufficient evidence supporting H1. Okay, so that's the last step of the hypothesis testing. Now, you might say that it was such a long process. Now, the thing about that is that it seems to be a long process because I explain the steps with all the details that you need to know. Now, in the next video, so I want you to watch an example on how I perform the 5 steps, and hopefully you'll be able to see that it will not take you more than 10 minutes in performing the test. Okay, so again, these are the 5 steps in performing the hypothesis testing. In this version, we numbered them 1 to 5, but the numbers are really just there to guide you, because as long as you put all the necessary steps without numbering them, and you follow them in a certain sequence that shows how the test will progress, and you end with the conclusion and the decision, then you have performed the hypothesis testing. The numbers are just there to guide you, but you don't need to put the numbers if you are already used to performing the hypothesis testing. Again, to perform the hypothesis testing, we can follow the 5 steps. The first step is the writing of the null hypothesis and the alternative hypothesis. Number 2 is the setting of the significance level alpha, determining what type of test to use, setting the decision rule, and the data gathering. Number 3 is purely the computation of the test statistic. Number 4 is the comparing of the value you obtain in number 3 with that of the critical values. And then number 5 is writing the decision and conclusion. So please watch the video that shows an example on how we perform a hypothesis testing on one population mean. In the video, you will see how these 5 steps will be performed.